Okay, oops. Okay, it just changed to 6:30. Now I can start. First of all, are there any questions about recursion? After last lecture, after you tried the assignment, right? So now maybe you have questions that you can verbalize. No questions? You know everything there is to know? Half of you have already done the assignment, so you probably know all there is to know. But okay. If there are no questions, just a reminder in case you don't read your email, that we are now getting close to the midterm. The midterm is on the 28th, which is Wednesday, 2 weeks-ish from today. Today is the 14th? Today is Monday, so it's the 12th. Wednesday is the 14th, so it's 2 weeks from Wednesday. So after we finish with recursion, we'll cover loops, and then loops will be on the midterm. So let's go back to this stuff. Okay. The idea of recursion, right, is that you will close everything. God, I have the world open. The idea of recursion is that you decompose your problem, right? You're given a problem, and the problem is hard. So what do? You transform it into a slightly easier one. And then to solve that slightly easier one, you transform it into a slightly easier one until you get to one that is so easy that you know the answer. Does that idea make sense? So, for example, power, right? And this we did last time, but this will be the initial thing. We are going to raise a int, a base to an exponent, and they're both going to be ints. What can we do? What's the easy one? What's the easy case? The one that's so easy that we know how to solve it.
Exponent equals 0.
When the exponent is 0, right? And what's the answer? Now, if not, what's the slightly easier thing we can do, right? Do one less, right? The exponent, make the exponent one less. That's the easier case. Does that make sense? So we are eventually going to do something and then have power base exponent minus 1. So this is slightly easier, right? I have one less. Does that idea make sense? Now what do I have to do to the solution to that slightly easier problem to make it the solution to my problem? I need to return the value, but do something to this value, right? What do I do to this? Multiply it times the base, right? Does this idea make sense? it is kind of a different way of thinking, right? Think of smaller problems and how you transform that solution to make it the solution to your problem. But it's a very powerful thing, right? In fact, it is equivalent to any program you could write. You can do all the loops and all the everything else we are going to learn in this class just with recursion. So it is a very powerful idea. This idea makes sense. Yes, you can do simple recursion in your sleep with one hand tied to your back. So let's start complicating things a little bit. One other way of doing recursion is having an accumulator. In this particular case, one slightly bad thing is that we have to transform that solution, right? There is a different way of writing our recursive programs that, and so just returning the value. So what we are going to do is basically pass that extra solution, right, to this. So we can do, let me call it POW2 just to have it a different name. And that's an accumulator. So what we are going to do is, the exponent is 0, we are going to return the accumulator. And so now we are going to convert this, right? So we are going to do power, still the base, still exponent -1. But what am I going to do with my accumulator, right? I'm going to be passing that next step on this solution, right? So this is base. This idea makes sense. Let's start JShell. Oh, I was here returning power and it should be POW2, right? My same method. In fact, let me do my standard cheating thing so we can see how it works. So what happens when we do POW2 of say 2 to the third power and my initial accumulator is 1. I call it, it's 2 to the third power and my accumulator is 1. Then it calls POW2 to the second power and now my accumulator is 2. Then it's going to call POW 1 more power, right? And now my accumulator is 4. Eventually it's 0 more power, so my accumulator is 8, and so I return the 8. Does that idea make sense? That accumulator carries my current solution. Why would you complicate your life? Which one is easier to understand? First one, right? Why would you complicate your life? In this particular case, because I want to complicate our life. No, there are two advantages. There's one potential advantage, which is that if your compiler is smart, it will generate a better code for this one. It will not have to use a stack because it can reuse the stack frame. You're just returning a new value, so it can just cheat and reuse that stack frame instead of pushing a new function call into the stack. Does that idea make sense? Every time you call a function, the computer needs to push stuff onto a stack saying, okay, here are the arguments, and eventually when you return here. And when you return from a function, it just pops those things, and the stack keeps growing and decreasing. And so this enables it to reuse the stack frame, and so never actually grow the stack. If you have a normal recursive function and you call it with really large values, eventually it blows up the stack. Right? Just do too many of those things. This way it wouldn't if your compiler was smart. Java compilers are dumb by on purpose. Actually, the default Java compiler is dumb on purpose. There's other Java compilers that you can use that are not dumb, and I think there may be ways to tell the Java compiler to not be dumb and optimize. This is called tail recursion. But we will do something now in a second that will be a similar idea. I also wanted to use it to introduce this idea that you may be passing more stuff to that function to keep some temporary values, some things that you're creating on the fly. Does that idea make sense? Again, what would we do to change the interface of that pow2 function, right? That pow2 function is ugly because you have to pass a 1 at the very beginning, right? So what would we do? Create a wrapper function, right? So that the people outside don't need to know about this. I'm not going to create the wrapper function because I'm lazy. Oops, sorry, in the interest of time, we'll not create a wrapper function. But, right, that is the idea of a wrapper function. Many times you will create it. Now, there is a cool sequence of numbers called the Fibonacci sequence. Fibonacci was a big mathematician or something like that at some point in time. He was Italian in the 16th, 17th century, something like that. Wikipedia is your friend. Among other things, he came up with this really cool sequence that happens to appear in many things in nature. It's also really cool for entertaining yourself when you're bored. I did it as a kid. I taught it to my kids, right? When you're bored in math class, you're done with this stuff, and you're waiting for everybody else. This one is actually fun to calculate. You start with 2 1s, and then you add up the previous 2 numbers. So the next number of the sequence is 2, then 2 plus 1, which is 3. What's the next number? 5. Does this idea make sense? So we can define what we want is something that when I pass it the a number n will tell me the nth number in the Fibonacci sequence. Does that make sense? So let's assume that this guy is 0, this guy is 1, right? Right? Does that make sense? That's just convention. We could have started counting at 1 or at 17. But so what's our easy case? So we have 2 easy cases, right? The first 2 numbers. If n is equals 0 or 1, what do we return? If it's not, what do we return?
Return fib times n, or plus n.
N plus fib, would that work? N plus fib of what? N what? N minus 1. Is this what we need? Let's try it with 7, right? What you are saying is that we would return 6 plus 13?
No. So delete the n.
Okay. So I have fib of n minus 1, and I need to add it with what? N minus 2? Is this what the...
No, the function.
Yes, fib of n minus 2. Right? Does this make sense?
Cool.
Let's try fib of 5 and see if we get 8, right? So fib of 8, we get 34, right? That is good. We got it. It works, right? What is a possible problem with this function? It works. That's the, right? The first thing. It should work. It works. Is it easy to understand? Yeah, right? Chances are that it's also right, besides working for the few things. The only problem is that its behavior is exponential. For every number, we call it twice, right? And so we keep, so if we call fib of 10, right? If you notice, fib of 8 actually takes some time to come back, right? Fib of 10 is going to take more time. Fib of 20, not yet. It didn't break. It's just taking forever. It's going to take between 1 and 2 forever. It didn't break. Yeah. So maybe 50 was too much. Let's try 25 and we'll see. 25 is still fast. 30 is still fast. 35, the thing is that it's exponential behavior, right? So when you add a few, right, it takes a lot longer. It returned, it just took a long time, right? Does this idea make sense? This would take a long time. So my problem is that for every number, right, I get 2 function calls. So I'm taking 2 to the n power, right? Which is exponential, which is another way of saying slow as molasses. So what can I do to not suck?
Don't allow anything above 40.
That works, and actually many times, right? That is what you do, right? Like, okay, I know that nobody's gonna call me with big numbers, so I don't need to go do something else, right? But if I don't have that luxury, what can I do? I can rewrite it by passing an accumulator. Oh, and it's gonna be fun. Maybe, yeah. Let's see. I would need to go the other way around. Oh. Yeah. Probably makes it clearer if I go the other way around. But we are going to pass it kind of the previous 1 and 2 values, right, that this would have returned. Does that make sense? It's not really the previous 1 and 2 because my n is going to be reversed. But so if n is 0, I'm going to return that one. I'm gonna subtract 1. What's gonna be the previous now? How do I calculate the next one from the previous? It is this, right? And the other one is this one. So now it goes to the next element of the sequence, right? And I have some horrible off by 1 thing. No, I need to cheat. I'm returning the right thing, but did you notice the difference in time? Now it takes linear time instead of exponential, right? So now I can do 100. This is actually broken the other way. It's broken because I'm past the maximum range of an int, so now it gets all confused. But yeah, it shouldn't be getting negative numbers. What happened is that I went past the maximum int and started wrapping around.
Yeah.
Could you explain a little bit more this primary 1 and primary 2? What is that? Is the position in the array?
There's no array, right? It's a sequence, but there's not actually an array, right? It is the previous 2 Fibonacci numbers that you have calculated.
So why are you passing all these 1 and 0? I mean, if the number is 100, why is the previous one 1?
Those are actually the first 2 numbers of the Fibonacci sequence. They're actually cheating. That's the cheating thing of counting the first 2 numbers. If you count the minus 1 element of Fibonacci would be 0. Right? So rather than saying 1, 1, 2, it starts 0, 1. Right? And so that allows me to, that was just a cheating device. My numbers are wrong. Let me do it this way. We start with the current number. And so instead of n being 0, n is the one that we want. Current is the one that we have calculated, right? And prev1 and prev2 are the corresponding ones for the sequence. Does that idea make sense? So I would start with, if I define it like this, and then let me do my standard cheating. So now I can call fib accum of, let's calculate the fifth one, current is 0. So these, in a way, are the Fibonacci sequence. But I'm going to be passing, right? So when I start, is 0, and the previous two numbers in the sequence are 1 and 0. This is slight redefinition, slight cheating, right? When you want the first element of the sequence, right, the previous two are 1 and 1. So this is actually the one that you should return. And then this is the previous one. So when current is 2, right, this is the current element in the sequence, and this is the previous one. What I did was cheat and say, oh, rather than counting till these are the same, I can just count this one down until it gets 0. But it's a lot harder to see. This one will probably be a lot easier to see. Does that idea make sense? I'm going to leave it like this. Forget that I mentioned the other one. But this shows you the idea of an accumulator in a very useful thing, right? I converted something from exponential to linear. I converted something from it's never going to work to, oh, I can do it and it's actually fast enough. Because computers are really fast. Doing it to 100 is a pain, but computers don't care. Let's do a couple more examples. Let's switch a little bit and do counting, which would actually mean we don't return anything, right? We are going to count, and we are getting, we are going to count up, and we are going to count from to 2. Does that make sense? And we are going to print it to the print stream that we get. How do we do that? And we need to agree whether we are going to count inclusive. Does that make sense? So we're going to print from and we're going to print to, right? How would we do this? What's our easy thing when we don't do a thing anymore? We're going to start imagining that from is 3 and 2 is 7, right? What's going to be our stopping condition? What's our easy problem where we are done? Sorry? And they're
From equals to.
from equals to 2, right? Actually, since we said that it's inclusive and we're going to count them, right?
From greater than.
It's from greater than 2, right? We can maybe prettify it later. Right? From is greater than 2, just return, right? Otherwise, what do? We are going to print a number, right? Print from. So out.println. And what else are we going to do? Print the rest of the sequence, right? So wouldn't it be cool if we had a function that would print a sequence of numbers? We do, right? Same out. Now, what do I change? From or to? From, and what do I do to it? Woohoo! What happens if I do this? Nothing gets printed because it was already bigger, right? Make sense? Any questions? Yes.
How do you, I still kind of am struggling with the exponent and then the linear concept.
Yeah.
How is that, how is that like different? One related?
How is basically what has happened, and yeah, so let's go back to this idea of linear and exponent, right? What happens here, actually, let me do this. Maybe this will help. Right? Let's do it and print it, right? So if I pass 1, life is good, right? What happens if I pass 2? 2, 1, and 0, life is good. What happens if I pass 3? I called fib of 1 twice. Does that make sense? What happens if I call it with 4? I call fib of 1 twice, fib of 1 3 times, right? And fib of 2 2 times. If I call it with 5, this is the standard, right? It's going down, and then it starts calculating those things. But in order to calculate fib of 3, I need to calculate fib of 2 and fib of 1 and fib of 0 again, right? And so it calls fib of 1 a bunch of times, 1, 2, 3, 4 times, right? And calls fib of 2, 1, 2, 3 times. Actually, it appears that it's not really doing exponential, right? it is doing quadratic. And I'm an idiot. 15, right? 4 took me 3, 6, 9. 5 took me 16 lines, right? So it's n minus 1 squared. 6 took me 1, 2, 3, 4, 5, 3, 6, 9, 12, 15, 18, 20, 25. So it is squared, not quadratic. I am an idiot. And that's why it wasn't taking that long. So it is squared, sorry. But you can see, right, what we mean, whereas the other one goes linear. I only have 6 or 7 or something like that goes. Yeah.
Are there any downsides to using an accumulator instead of doing it the other way?
To me, and a lot of times it depends which one is easier to understand. Which one is easier to understand, the first one or the second one?
First one.
That's the downside to using an accumulator. Until you have done 700 and then accumulators become natural and you don't even think about accumulators as hard. To me, accumulators are kind of not natural. They don't go with the definition of the problem. They're kind of a hack or a computation to make it go fast. And so the more natural solution is more natural, but if you think about it, those two are matters of type, right? I like it better, but you may feel the other one is more natural. Its philosophy is not easily quantifiable. If you work on a programming language that pushes recursion and doesn't push loops, you end up doing a lot of accumulators and you end up seeing them as completely natural. I still don't. I do see recursion as very natural, but not accumulators. Hopefully I can pass on you a little bit of the taste for recursion, so that even when we see loops and you end up doing loops, most problems are fairly easy to do with loops or with recursion. And Java has a wide variety of loops, so we tend to use loops much more than recursion. But hopefully the idea of recursion will stick, because there is a bunch of problems that are not easy to solve with loops. And so when you need to do those, recursion would come natural. That's why we cover recursion before loops, so you actually use it. And that's why I tried to do a gajillion examples. But that's the cost, right? Accumulators make it uglier, harder to understand. More variables, and you have to add wrappers and things like that. On the other hand, it makes it fast as hell. So the trade-off may be useful. Meta thing. How do you know if something being fast matters? Does it always matter? Is faster always better? Yes, as long as there is no cost, right? Is faster but uglier always better than slower but simpler?
Depends on what you need.
Your user eradication.
But also, if you think about it, many times there are things that we are doing a gajillion times in our application, and so on those, yes, faster, right? There are things that it may be that fast doesn't matter, because fast may mean 1 millisecond instead of 2. Does anybody care? Probably not, right? Now that depends, right? If it's 1 millisecond instead of 2 inside a game loop, then that really means 30 frames per second instead of 15, and then people care. For no particular reason, but you do care, right? You want more frames per second. Even though there is no way you can see anything, but feels cool. Whereas faster on initialization, taking 1 millisecond instead of 2, nobody gives a hoot. So it depends on what you're doing. Does that make sense? Premature optimization is the root of all evil. Eventually, you will kind of get, yes, if you can do something faster for 0 cost, by all means do it. If not, well, then decide and measure, right? Don't make it faster, make it easy to understand, make it work right. And then if you ever need to make it faster, measure, make sure that you're actually making it faster instead of slower by some other reason, and then change it. So we were doing counting up, right? Shall we modify it? Let's modify it so that we add a step. So we count by 2s or by 3s or by 25s. Right? What would we need to change on our function? If from is equal to 2, what do? We still return, right?
From plus step?
Yep.
Okay.
This is the only thing that we need to change. From 1 to 10 by 2s. Oops. Oh, it is, huh? No. What's it doing? Oh, I'm not passing the step here. So it did something. Oh! I didn't pass this step here, so it was calling the old function. That still exists. Is this cool or what? What? Can we rewrite the if? Do you guys like this way, or would you rather have it so that we guard it the other way? We could write it this way. Which one is nicer? 6 of one, half a dozen of the other.
Yes.
Any particular preference? No. I mean, leaving it like this because this is what it is right now. Now. Oh, sorry.
What's that?
Would you mind asking?
Yeah, the counter over there up top, you put two from and two.
Here, from?
In the
Wow.
comments.
Yeah.
Oh, from to to.
Yeah.
Because my variable name is from,
Okay.
right? So my English sucks, but that's the name of the variable. Maybe can we come up with better names for the variables, or
Just capitalize them.
sorry?
Capitalize them.
Capitalize them. Make them italics. Yeah. I polluted your brain and made you think that from and to are good names for variables. I tend to name the variables from and to. That to me that makes perfect sense. But now take your pencils. Do it counting down, right? From in this case it's gonna be it's supposed to be higher than 2, right? So you count from 10 to 1 by, shall we make our step positive? Right? So by 1, right? Or by 2. So you're counting from 10 to 1 by 2. So 10, 1, and 2 rather than minus 2. Does that make sense? Do you understand what's the cool? Then write it, or type it, or do something with it. Yes.
I read in the book, and I tried this myself, if you just move the out.print below the
Oh! What would happen?
it would go reverse.
Probably. Yes. You just destroyed my exercise. Possibly. Yeah. Oh, but that's still not exactly what you're asked. Right? What I'm asking you is that when you do, it's almost, I'm asking you to make it so that it works like this. Yeah, that is cool. Yes, that would reverse it. If you invert the action versus the recursive call, right? That would reverse it. So it's almost right. Group programming is always nicer. I hadn't thought about it that way. So dictate to me. I'll do it right there. Anybody who's not on the first row, dictate to me. Okay, I'll help you get started. What do we want to have as conditions? When do we know that we're done? You guys know it, you guys wrote it, don't be shy. It's perfectly okay to be wrong. We'll test it and we'll fix it. These are computers. If you are not used to being wrong, you're not going to succeed here. We are wrong 80 times in a day, right? You just fix it and you make it suck less until it sucks little enough that you can put it in production. Your code will have bugs in production. Such is life. It will never be perfect.
So depending on whether from is less or greater than 2, you may need to switch.
Yes, so we said that from was going to be bigger than 2. So print count down, say, system.out from 10 to 1 by 2. This is what we want, right? So what is our stopping condition?
When from is greater than or equal to 2.
Okay. And so we're going to structure it like this one? Or?
Yeah.
Yes, okay.
And then instead of from plus step, do from minus step.
Yeah, probably. Sounds good to me. What do you guys say? Looks reasonable? Oh, of course. Cut and pasting sucks. Let's see. Sorry?
Yeah.
If we had 2s, then yeah. Cool. Thank you.
So, like, could you have done it from 2 instead of from?
You could by doing history. So we could have done this. I mean, you can always do. If you start directly from 2, you would count reverse, right? But you can do this, which is what he did, right? So this is almost right, except that it has from and to inverted, right? So you can just cheat. The client doesn't know, right? It's just whatever names you gave to your things. It works. How do you change this? But I didn't want him to ruin my teaching moment.
Sorry.
This would probably work, right? As you may have noticed, there is 1700 ways of achieving the same result, right? There are better and worse solutions. Well, first of all, there are probably 10 reasonable ways of doing this, right? There is an infinite number of wrong solutions, right? However, there is maybe, I don't know, 5 or 10 ways of doing this that would be reasonable. Many times there are some that are kind of definitely better than others, but there may be 2 or 3 equivalent solutions that are equally good or bad. I hate this one, but that's me. I need to keep track of this stack as opposed to say, oh, now I'm done. So to me, this one requires more of my brain. The fact that the recursive call is at the beginning, I still need to keep track of what's going to happen next. So that causes extra memory space in my brain. But I wouldn't say that it's terribly worse. It's just more confusing to me. Get used to the fact that there is no right answer. There are many right answers and many more wrong answers. So. Let's do another one that is fun just because it's fun. Everybody should do compound interest at least once a year, right? Just because we don't realize So we are going to calculate what happens when we compound interest on something, right? We're not going to add it, just calculate the interest, right? Calculate the ending sum, right? The ending amount. So you have a principal, you have an interest factor, right? Depends on how you think about it. If it's a 5% interest, then the factor is going to be 1.05 or something like that, right? So that's how we're going to pass it, right? And then, so what happens when you compound something for 30 years, right? And you don't pay any capital. What happens?
Foreclosure?
Yeah. So what do we do? How do we calculate it and then we'll play?
Number of steps is greater than 0.
Number of steps is 0, right?
We could also do if interest factor is 0, return principal.
If
Shouldn't the number of steps be equal to 0?
yes, probably less than or equal to 0 just to be. Just to be paranoid. It should be equal 0. The less than or equal is just in case somebody calls you with that negative number of steps. Else, what are we going to return?
But if the interest factor is 0, it will return 0.
It would return 0 eventually, yes. Right? Depends on the number of steps. If there are 0 steps, then no. Which makes sense, right? It would multiply it by it. So if the interest factor is 0, then it would return 0. Keep in mind that the interest factor in a way is +1. Right? So if you have 5% interest, right? The interest factor is 1.05 rather than 0.05. Let's try it. So if you borrow $1,000, right, at 5% interest for 30 years, you would need to pay $4,000 at the end, right? If the interest was 8%, you need to pay $10,000 at the end. So a small difference in interest, right, ends up being a huge difference. You should do this at least once a year because we end up taking mortgages for 30 years or taking student loans to pay for classes or something like that. So you need to be aware of what happens. And what happens both ways, right? However money you save now for your retirement, in 30, 40 years when you retire, is going to be a ton of money. Potentially, if you survive. Don't worry, mortality rate is still 100%. You're not getting out of here alive. But it's always a good idea to look at this again, right, and start playing with those things. Shall we do binary search, high and low? Let's do it one way. This will kind of, the n is the number that was guessed, right? And so you would, it would tell you, it would ask the user, guess a number, right? Or actually the other way around, it would tell the user, I've guessed a number. And then the user would try to guess, I've come up with a number, the user would try to guess, and the computer would eventually say high or low, and the user would keep guessing. Does that make sense? So the computer would come up with the number rather than guess the number. This is probably not terribly useful, but maybe. So we can do high-low of so guess the number, I guess 34 when it gets all confused. I'm messing up with the repulse scanner, which is bad. Never mind. Isn't this cool? And it's not worth doing a full program. It wouldn't work because when we do system.in, we confuse this. This guy is trying to read from system.in at the same time as we are. JShell is trying to read at the same time as we are. And so it gets all confused. So we can't do that one. We can't do the other one either. We need to start a real Java program in Eclipse or something like that. We have about 6 minutes. Let's do GCD, just because it's really cool. You remember they probably tortured you with this in middle school? And GCD stands for Greater Common Divisor, right? Yeah. It's the highest number that divides both A and B. There is Euclid, which was a Greek guy who invented half of math, came up with an algorithm for doing this that is recursive. Basically, if B is 0, return A. Else B modulo A. Right? A modulo B. Oh yeah, because A is the bigger one. Sorta, kinda. It happens to work, which is really cool. It's just cool that it works more than anything else. Sorry? Least common multiple. How do you calculate the least common multiple? There is basically A times B divided by GCD of AB.
Oh, yeah. Yeah. Literally an hour ago.
They are the same thing in a different way. Yeah. But probably in middle school they tortured you with decomposing into prime factors, which is a cool thing too. Yeah. I think I'll return 3 minutes of your life. Now I'll see you guys on Wednesday.